Hi biology students, this is Mrs. Miller, and today we're going to be continuing with our ecology unit. Today we're talking about section 4, cycles and climate change. Today we're going to focus mainly on the cycles. So we've previously talked about what happens to energy within an ecosystem. We know that energy comes from the sun. That sun is then going to give its energy to producers, and then those producers get eaten by consumers. It's a one-way path that doesn't recycle. So that means that energy and matter are going to move through the biosphere very differently. So again, sun to producers to consumers, one-way flow. However, what we're going to see is that matter is going to be recycled within and between our ecosystems. So we're never going to run out of that matter. Elements, chemical compounds, and other forms of matter pass from one organism to another and from one part of the biosphere to another. There's going to be two cycles that we're going to look at today. One is going to be for an element, one is going to be for a chemical compound that we're going to focus on, and that's going to be the water cycle and the carbon cycle. What I want you to notice here is that this is going to look different than what we talked about with energy. Remember, energy, it just went from sun to producer, I'm just going to put a P, then to consumer, and it went in that one direction. What we see when we get to all of these elements or chemical compounds is it's cycling, or we're going to see this constant circling around. So the big thing that you guys need to know and to understand is that matter can cycle through the biosphere because biological systems do not use up the matter. Instead, they transform it. So what we have here, one of the big things that we're going to follow is carbon. And here we start with carbon dioxide. So that carbon plus the sun is going to go into our producers. Our producers are then going to go in and they're going to make glucose. Okay? That glucose then is going to go into this caribou. The caribou then is going to excrete its extra matter that it doesn't need, and that in this case is going to be eaten by this little beetle. This little beetle then gets eaten by the mouse, who gets eaten by this hawk, and as that hawk is going through, it's going to go through respiration, and it's going to be producing carbon dioxide, which again is going to go back to those producers. So it's this constant cycling of matter that's really, really unique in an ecosystem when we compare it to that energy. The water cycle is something that you guys are probably already used to. We've talked about this before, probably in different science classes. So we know that water is constantly being recycled within the biosphere, or the area where all life is going to exist on Earth. Here we can see a picture of the water cycle. Last year my students had this ridiculous song that they memorized about the water cycle. So if you know it, I'm sure you know all these parts, like evaporation, condensation, precipitation, and then we are going to go through and run around this whole cycle over and over. One of the big things that we see on Earth, of course, is evaporation. We know that evaporation is the phase change of water from a liquid to a gas, and energy gets absorbed. So heat energy is going to go from the environment, goes into the water, and those water particles speed up and they start to evaporate. This is the primary means of which water enters into the atmosphere. So on a hot summer day, sometimes it kind of looks hazy above a big body of water, and that's just all that water that's evaporating. So sunny and warm days tend to have very, very high evaporation rates. Then that water condenses up in the atmosphere, and eventually there's so much of it sitting in the clouds that it has to come back down to Earth. The one thing that you probably haven't heard of before is something called transpiration. You notice that it's a smaller arrow than evaporation, but transpiration is the evaporation of water that is released from the leaves of plants through normal metabolism. So as a plant is going through and creating its food throughout the day, it's going to evaporate a little bit of water out of its leaves. So that's another way that water can get up into the atmosphere. The other cycle that we're going to talk about is the carbon cycle, and this one is probably not one that you guys are nearly as familiar with. We know that carbon is the key ingredient in all living organisms. Remember, we talked about organic substances, they have carbon and hydrogen. Well, Almost everything on Earth has carbon in it, especially anything that is living definitely has carbon in it. So less than 1% of Earth's carbon circulates within or through the biosphere by 4 different processes. So we could see that it's going to happen through photosynthesis, respiration, and decomposition. Okay, so normal like biological processes. Sometimes we're going to see that carbon dioxide gets released into the atmosphere with volcanoes. So a few years ago we had Kilauea on Hawaii that was erupting, and that put a lot of carbon dioxide into the atmosphere. Turning buried organisms into coal or petroleum, so things that die and they get buried, that's where we find coal and petroleum or natural gas as well. But another big one that we're starting to see more and more of is human activity. So human activity could include mining, combustion of fossil fuels, destruction of forests. Anything that a human can do, like even driving their car, is going to increase the amount of carbon dioxide that is in the atmosphere. Carbon is going to be held in several different areas in the biosphere, including the atmosphere, oceans, land organisms, rocks and soil, and then underground deposits. So here is what we see with the carbon cycle. As you can see, there's quite a few arrows going up into the atmosphere. So one big one that we just talked about is volcanic activity. Anytime that a volcano erupts, it's going to put a lot of carbon dioxide into the atmosphere. As animals and all organisms go through respiration, it's also going to be releasing that carbon dioxide out. Oceans are going to release a little bit of carbon dioxide as well, but a really big one that I previously mentioned is human activity. Factories, cars, burning of fossil fuels. These are all going to increase the amount of carbon dioxide in the atmosphere, and that can really have negative effects overall on our ecosystems. The way that we get carbon dioxide back out of the atmosphere, the number one way is through photosynthesis. So we allow plants to go through their regular process to produce their food, and that reduces that amount. Otherwise, carbon dioxide can also go down into the ocean. You can see a few other things, like as organisms feed on, like our elk is feeding on whatever our producers are here, that carbon is moving into the animal and then it goes back up through respiration. We could also see that we could have plants that die and get buried, and then we could have these fossil fuels that are created, and that can go back up into human activity, which eventually goes back up into the atmosphere. What I really want you guys to know and to understand from this is that, again, all of these arrows are able to go and cycle in all different directions, but we're not losing any carbon dioxide at any state of this. So there's a reason why we chose carbon to look at as we were creating this video, because carbon has a huge impact on the environment, specifically with global warming. So global warming, which is also known as global climate change, refers to the recent increases in Earth's average temperatures. So during the last 100 years, surface air temperatures have increased by 1.33 degrees Fahrenheit. I get it, that doesn't sound like a lot, but overall that's a huge increase, and it's pretty dangerous. Greenhouse gases, especially carbon dioxide, methane is another good example, is one of those big greenhouse gases that can increase the temperature. They correlate to temperature changes and are currently seeing the highest climbs of carbon dioxide levels in history. So what happens is that carbon dioxide is in the atmosphere, and it doesn't allow sunlight or the heat from the sun to escape our atmosphere. It bounces back toward the surface of our Earth, causing us to stay warmer than we should. So carbon has always cycled. What we see here is a graph that shows us carbon dioxide levels from 400,000 years before all the way up to today. This is actually from like 2015 or something like that, so it's a little bit old. But what we can see is there have always naturally been these times where carbon dioxide levels have been high and where they've also been low. So they have naturally gone up and down over these past 650,000 years, okay? The thing is, the big problem is the fact that we are at such a peak right now that this is causing a huge issue, and we have way more carbon out in the atmosphere than we've ever had before. That is causing our overall temperatures to continue to increase, and at some point we're going to get to such a warm temperature that our polar ice caps are going to melt, that our water levels are going to rise, that certain areas are going to be underwater. It's going to be very, very bad if we don't figure out a way of how to level that off. So again, what I want to reiterate is that climate change is not uncommon. We have naturally seen periods where it's gotten warm, and we've naturally seen periods when it's gotten cold, like the different ice ages. However, it's that current spike that we're seeing of carbon dioxide in such a short period of time that's very, very worrying to scientists, and we really want to try and scale back on the amount of greenhouse gases that are going into our atmosphere. Scientists agree that global warming since 1850 is caused by a rise in carbon dioxide, which is directly in relation to human activities. Primarily, this is burning of fossil fuels, but it's also continuing deforestation and changes in land use. The deforestation, it's because our plants are gone, so we don't have that ability to pull the carbon dioxide back out of the atmosphere. So what we'd really like to do is to limit the amount of carbon dioxide that goes into the atmosphere, plant more trees so more of that comes back out, and we can kind of clean up our atmosphere a little bit. We'll talk a little bit more about climate change later on, but if you guys have any questions, please let us know. Otherwise, have a great day.